So just going to do a quick example on simplifying indices. So I've done this sort of question in the practicals, but it's also one of the types of questions on your exam. So a couple of things we have to pay attention to. We've got a whole lot of power rules, etc. going on, and we also in this question have some of the indices expressed as fractions. But essentially we still follow all of the same procedures that we do with powers, etc. And we can approach these in a few different ways. So with this one, this is how I'd go about doing it. So firstly, I'll probably simplify what's going on inside the power here. So I'll leave this x to the 4/5 out here. Remember when we have an index and terms inside the brackets, when we take the power, this multiplies the indices that are inside the bracket. So here I'm going to have x to the negative 12 on 3. And then I'll leave this at the moment as x y to the negative 3. Now, when I've got a division, rather than doing this as a negative and positive and changing around things first, one thing that we can do is just express it as a string. So convert these to negative and positive. So this equation here is going to be x to the 4/5. X, in this case, this is 12 on 3 is 4, so this is x to the negative 4. This is x to the negative 1. And this is y cubed. And so now once I've got it sort of all as a string, I can just apply the addition rule for all of these x's. So I'm going to have x to the 4/5 minus 4 minus 1, and then y cubed. And so this gives me 4/5 minus 5, which is going to be negative 4 and a fifth, or x to the negative 21 on 5. Can also get to that by saying that minus 5 is the same as negative 25 on 5. Multiplying by index, and then get y cubed here. So the things to pay attention to here is that when this x and this y get moved to the top here, the index 1 and 3 become negative, 1 and negative 3 become negative 1 and 3. The other thing is remembering that for these brackets, whenever we have brackets, we have to multiply in here. And with fractions, we still treat a string like this. As long as they're all to the same base, we just add those indices together. But since y is a different base, we don't add them together. Okay.